Hi everyone, this is Jerrid Kruse. Jesse Wilcox and I have an article published in this month's issue of the Science Teacher that explores density and sinking and floating and helping students really develop a conceptual understanding of why things sink and float and related to density. So we oftentimes assume that kids understand density and sinking and floating when they come into our high school classrooms, but when we push them a little bit further, they struggle. For example, when we ask them which of these two objects will float, they easily say that the golf ball will sink and the cork will float. And when we put them in the water, their predictions are held up. However, when we ask them to explain why, they oftentimes will say things like density, or they might even be able to tell us the formula for density. But when we ask them to explain a little bit further, but why is the formula for density what it is, or what does density really mean, they struggle and they revert back to talking about the heaviness of things or how much mass something has. So to confront this idea, we give them two new objects, a paperclip and a bouncy ball. And when we ask them which of these will float based on their thinking, they recognize the flaws with their thinking about mass. And so when we put the paperclip in, it sinks, and we put the bouncy ball in, the more massive bouncy ball in, it floats just below the surface. And so through these activities and some questioning, we help them realize that both mass and volume have an impact on floating and sinking. At this point, we help the students generate some ideas on how we might collect data to refine our thinking about sinking and floating and mass and volume. And so we decided to collect mass and volume data and floating data on a whole bunch of different objects, some that they bring in from home and some that we provide. What we end up with is a graph similar to this. And so you can see that the X's represent things that sink, the dots represent things that float. And the space in between ends up being somewhere around the slope of 1, or where mass and volume are equal to each other, and we all know that that slope is equal to the density of water. But through discussion and helping kids really wrestle with what this data means and trying to interpret this data, we help them understand why that space is there, and then we also investigate the density of various amounts of water, and we end up actually plotting the density of water on this graph. And through all these activities, the students start to really understand some of the reasoning and conceptual understanding behind the formula for density. Then in our next activities, which we'll talk about in a different video, we really help the students start to apply their thinking and develop a more conceptual level of understanding for density.